So whatever naturally available chemical compounds are there in our nature, they are divided into various three different types based on their nature. Okay, so first one is compounds. Some of them are mineral origin, available only in the form of minerals. As you are aware of it, minerals are available in the soil. Some of the compounds are available in the vegetables or vegetable origin compounds, carbon compounds that are present in our day-to-day life vegetables, beetroot, carrot, etc. And third one, compounds that are exclusively available from animal based products. That may be a dairy products, that may be a egg, meat, etc. Whatever carbon compounds present in animal origin, they are classified like this. Three different compounds based upon their origin by Lembre. And after that, a great scientist called Lavoisier. Who is that? Lavoisier. This scientist generally showed that all compounds obtained from vegetables and animal sources always contain, okay, so whatever compounds obtained from animal sources that are always having or that are always made up of carbon and hydrogen. Carbon and hydrogen. Even the plant based products or plant based outputs or plant based end products, maybe a starch, it may be a polysaccharide, it may be a glucose, it may be a fructose, it may be a different type of plant based outputs, animal sources, animal byproducts like as you are aware of it, animal products like meat, eggs and etc. are generally contain carbon and hydrogen. In the classification of organic compounds, a great scientist called Berzelius. Who is that? Berzelius. A great scientist called Berzelius introduced the new term. He is the only scientist introduced the term called organic and inorganic chemistry. So whatever organic and inorganic compounds are there, okay, as per the vital force theory, he has proposed a theory called vital force theory. As per the vital force theory proposed by Berzelius, organic compounds from living organisms, they were produced under the influence of vital force. Whatever organic compounds that are going to come from living organisms, okay, living organisms which includes plants and animals. The organic compounds coming from plants and animals, especially their origin, if you take the production of organic compounds in plants and animals because of an important force present in the nature. Hence, vital force theory proved that plants and animals only can make the organic compound. Okay, so apart from vital force theory, if you take organic compounds only can be made in the nature by living organisms, but urea was the first organic compound that should be or thought to be prepared in the laboratory. Okay, artificially it was prepared in the laboratory. So who was the scientist prepared first organic compound urea in the laboratory? A great scientist called Wöhler for the first time prepared organic compound called urea in the laboratory, and vital force theory has lost its significance by synthesis of urea. And after that, one more equation I will show to you. Here let me tell you one of the equation. So after vital force theory, there are many scientists done their experiments in organic chemistry. So what is the Vogler synthesis of urea? If you take NHE4, let us take NH4ClO, which is nothing but ammonium cyanate. So Vogler took ammonium cyanate, and so using ammonium cyanate with the help of a synthesis process called tautomerization. What is that process called? Tautomerization. He successfully extracted urea NH2CO NH2 in the laboratory. So the chemical formula for urea is NH2CO NH2. So ammonium cyanate was the chemical which he was used to synthesize it. So first organic compound that should be, or that to be prepared from its own element, okay, in the lab is CH3COOH. Okay, acetic acid was the first organic compound which was prepared. It was prepared by a great scientist called Kolbe. A scientist called Kolbe for the first time prepared first organic compound by its own element. Got my point? Second organic compound which was prepared from its own element in the lab is methane CH4. It was prepared by Berthelot. So second organic compound that should be prepared from its own element is CH4 by Berthelot. Who is that scientist called? Berthelot. The element with the ability of carbon atom to form a long chain or rings is known as catenation. So what do you mean by catenation? The carbon has a property of forming long chains and rings, okay, compounds like long chains and rings. The formation of long chains and rings is nothing but catenation. Carbon is tetravalent. Tetravalence of carbon was proposed by Want, Hoff and Label. So here, as you are aware of it, tetravalence of carbon can form 4 different bonds with 4 different elements. Tetravalence of carbon was proposed by a great scientist called Want, Hoff, and another scientist is Label. For the first time they were successfully what we can call proved the tetravalency of carbon. Okay, carbon is generally organic compounds and they are numerous in number, almost due to carbon that possesses maximum catenation capacity. So the carbon contain maximum catenation character, which means it can form a long chain. At the same time, it is tetravalency in nature, can form a bond with 4 different elements, hence it is tetravalency in nature. At the same time, carbon generally undergoes for isomerization. Okay, what do you mean by isomerism? We are going to learn in the further coming topics. It has a great capacity of isomerization and a tendency to form a multiple bonds. Carbon can form multiple bonds with different elements. As a result of it, carbon is very separate element or compound can available in the form of compounds. Hence, carbon forms different types of compounds in the nature or in the earth crust layers. And significance of tetravalency of carbon and shapes and organic compound. Okay, hybridization. What type of hybridizations are generally seen in the carbon? So let us take a tabular formula. I have a tabular formula for representing carbon. So total together 1, 2, 3, 4, 5, 6, 7. So first one, second one, third one, fourth one, fifth one, sixth one, and this is seventh one. Now what I have to do with this 7 columns, let us see. So this is representing, okay, carbon and its characters. In the first column, hybridization reactions I have to take. So what are the hybridizations that are commonly possessed by the carbon? sp3 hybridization, sp2 hybridization, and sp hybridization. So what are the orbitals? What are the common orbitals that are involved here? Commonly, if we take one s orbital is there and 3 p orbitals are there in sp3. Okay. Whereas in sp2, one s orbital and 2 p orbitals are available, and one s orbital and 1 p orbital commonly available in the sp orbitals. Okay. Percentage of characters of orbitals. Let us know the percentage of character of orbitals. Okay. In this section you see for s orbital and what is its character, and for p orbital what is its character we have to know. So if you take the sp3, okay, and s orbital contain 25% of character of orbital, whereas remaining 75% orbitals are p orbitals. In the similar manner in sp2, okay, let us take sp2, 33.3% of s orbitals and 66.6% of p orbitals are there. Whereas in sp orbitals, if you take 50% of s orbital, 50% of p orbitals are commonly present. So what type of bonds are present here? Let us know some of the bonds that are formed by the different orbitals. Bonding, if you see in sp3, okay, almost all are sigma bonds. What is that symbol indicates? Sigma bonds, and there are no pi bonds. Whereas in sp2, 3 are sigma bonds, 1 is a pi bond. Whereas in sp orbitals, 2 are sigma bonds, 2 are pi bonds. Okay. Bond angles. Let us take bond angles here. Bond angles, if you carefully observe, 109 degrees, okay, 28 minutes. It is the bond angle for sp3 hybridization, whereas 120 degrees for sp2 orbitals, whereas in sp it is generally 180 degrees of bond angle commonly observed. After bond angle, let us take orientation of orbitals. So, orientation of orbitals, general arrangement of orbitals. So, how this orientation of orbitals commonly observed here? Okay, in sp3 tetrahedral type of sp3 orbitals are having orientation, whereas trigonal planar trigonal planar commonly observed in sp2. Last one, linear type of shape orbitals are commonly present in sp. So orientation of orbitals says about their shape and their structure. Got my point? So for carbon compounds, this is the hybridization and orbitals and their percentage of character, nature of bonding, bond angles and orientation of orbitals. Okay, sp3 carbon is called saturated carbon. Here some interesting features I will mention. sp3 carbon is called saturated. What do you mean by saturated? Most of the carbons which are dissolved in the different solutions or liquids, saturated carbon contain the sp3 hybridization, whereas sp2 sp they are not coming under saturated carbon, which means they are under unsaturated carbon. Carbon which is not dissolved in the compounds is unsaturated carbon with the sp2 and sp hybridization process. Okay, the order of size of different orbitals is okay, so that if you carefully see p and sp3 and what is after that sp2 and sp and after that s orbital. This is the order, structural order based upon their size. Okay, and it was arranged like this. After that, if you take carbon compounds, different types of carbon compounds, we are going to see. Glory వచ్చింది హెల్ప్ నాకు అది కావాలి కాదు